Welcome back to the deep dive. Sometimes the sources we dig into, they just drop you into a world that feels, well, frankly, like science fiction.
Yeah.
Today is one of those days. We're taking a trip that seems to start almost in ancient Rome, philosophy-wise, but lands right on the bleeding edge of the Solana blockchain.
It's quite the jump.
So our deep dive today is centered on this document, a foundational charter for a really sophisticated automated trading support engine. It's called the House of War Copilot.
And it really is an unusual mix. You're right. We're not just looking at what it does, automated market stuff, trading, but we need to get our heads around the philosophy underpinning it, the bedrock that's supposed to guarantee its survival.
Exactly.
The whole mission here is to figure out how this system is designed not just to survive market chaos, but to actually thrive on it. It's built entirely on this principle of anti-fragility.
Right. Anti-fragility, getting stronger from stress. And this charter, it's not just tech specs, is it? It reads more like engineering doctrine mixed with, a philosophical code.
Sure. Yeah, an ethos. It operates under the guidance of someone called Lord Michael War, quite the title, and it has this really powerful multi-generational goal stated right up front.
Which is?
To endure, to prevail, and to grow stronger from shock. So you see, it's not just about keeping the lights on. The aim is explicitly anti-fragile flourishing.
Anti-fragile flourishing. That's a bold statement.
It is. And that ambition, that whole idea is kind of crystallized in this Latin motto they use. It seems to govern everything, every line of code, every decision. We should probably define that right away, actually.
Good idea. It sounds important.
It is. The motto is via virtute, de contentione, rober, to discrimine, most, ex ruina, regula.
Okay, let's break that down for everyone listening. What does that actually mean in practice?
It translates roughly to the way of virtue. Okay, that says from tension strength, from discernment method, out of ruin, order.
From tension strength, from discernment method, out of ruin, order.
Exactly. So what it's telling you right from the start is that this system looks at market chaos, the contention, the tension, the ruin, not as threats to be dodged, but as the necessary input. The raw material needed to generate strength, rober, and definitive method, order, regula, comes from ruin.
Wow. Okay, that completely flips the typical risk management playbook on its head, doesn't it? Avoid chaos at all costs. Nope, this thing eats it.
Pretty much. It's designed to metabolize it.
All right, so let's dig into the rules then. If anti-fragility, benefiting from volatility, is the absolute goal, what are the non-negotiable imperatives, especially if it's meant to withstand what the charter actually calls extinction-level events? That's intense.
It is intense language, and they lay out 4 core behavioral rules. These really dictate how the system must react under stress. Rule number 1 is maybe the most provocative: profit from disorder.
Profit from disorder.
Well, when the environment degrades, when things get chaotic, the system is strictly ordered to do 3 things at once: increase signal, which means measure more, model better, decrease drag, simplify paths, remove friction, and widen option sets.
Widen option sets, so more strategies, not fewer.
Exactly. Activate multiple viable strategies. So think about it. When a typical hedge fund might be hitting the panic button, contracting risk, pulling back.
Right, hunkering down.
The House of War Copilot is designed to actively look for more entry points, to open up its strategic aperture. That takes incredible confidence in the underlying system.
It really does. Where does that confidence come from?
Well, that leads straight into rule number 2. Prefer redundancy over precision. Now, this is fascinating because in something like high-frequency trading, precision and speed are usually treated like gods, right?
Absolutely. Every microsecond counts.
But here, they explicitly prioritize having multiple partial safeguards over relying on a single, supposedly perfect system. The charter demands plural channels, plural data sources, plural fallbacks, everywhere.
But isn't redundancy inherently slower? Doesn't checking 3 sources instead of 1 add latency? And latency can kill you in crypto markets.
It does introduce a cost. Yes, a slight drag. But they clearly see that as a trade-off worth making. They're reducing the risk of a catastrophic single point of failure.
Okay, so it's about endurance over speed.
Exactly. The primary goal is endurance, not necessarily winning every single millisecond race. If one data feed breaks, or worse, gets compromised.
The system still functions because it has others.
Right. It has backups, potentially operating concurrently. That's the anti-fragile choice. Guarantee survival, even if it means sacrificing some theoretical maximum profit on a given trade. Rule 3 follows right from this. Bias to reversibility.
Meaning?
Favor actions that can be undone easily. low, irreversible downside.
Yeah.
And if it must do something irreversible, it has to be explicitly ratified, double-checked, reducing the chance of immediate fatal regret.
Makes sense. And the fourth point sounds like it's about learning from mistakes.
You got it. Localized pain, globalized learning. Failure must happen, but it has to be contained within small, isolated compartments. And here's the kicker, a direct quote. Every error funds an upgrade.
Every error funds an upgrade. Wow.
Yeah. So failure isn't punished, it's treated as a valuable resource. Once that localized pain happens in a bad trade, a system glitch in one small module, the system's response must ensure the lesson learned is immediately baked back into the whole system, usually as a new guardrail or invariant check.
So the same mistake can't happen again.
That's the goal. Strengthen the global system from local failures.
This philosophical depth, it seems to go way beyond just code structure. They use some pretty unusual terms for the system's institutional standards, like a syncretic Zen-Stoic framework.
Right. Attentive yet unmoved, empty of delusion, full of duty. It's like they're programming a warrior monk.
It sounds like they're demanding the mental clarity of that monk while executing, incredibly complex algorithmic trades.
They are. And that leads to two really unusual mandates mentioned in the charter, psychotechnics and framecraft.
Psychotechnics. What on earth is that in this context?
They require it of the human overseers, actually.
Huh?
It means cultivating, and this is their phrase, non-substance ethogenic states through disciplined attention and visualization.
Okay, let's ground that a bit. In simple terms, what are they asking for?
It's essentially advanced mental resilience training. Think intense focus, meditation, visualization techniques, all designed to expand the solution space, the ways you can think about a problem, especially under extreme stress, without resorting to, substances.
So radical cognitive discipline for the humans involved.
Exactly. So that when the system is going haywire, the human element, or maybe even the system's own adaptive logic, doesn't just freeze up or suffer from decision fatigue. It's about maintaining absolute composure and clarity when facing maximum chaos.
And framecraft.
Framecraft is coupled with that. It's the required ability to switch perspectives instantly, to look at a single problem through multiple lenses, simultaneously technical, strategic, ethical, temporal, even symbolic.
So seeing the whole board, not just the single piece that's malfunctioning.
Precisely. They want the system and its controllers to grasp the full context, not just, the immediate technical glitch.
Okay, now let's get to the engineering meat, the operational doctrine. This specifies how these, frankly, very demanding ideals actually translate into code and actions. If the philosophy is Zen-like detachment, what's the rule for, say, a network request?
It translates into hard, foundational principles for action. The very first one is truth over tempo.
Truth over tempo, meaning?
Correctness always trumps speed. Always. They are explicitly willing to be slightly slower if it guarantees they are right.
That flies in the face of a lot of high-speed trading philosophy again.
It does. And it's followed by small, safe steps, prefer tiny incremental changes that can be verified quickly, and idempotence.
Idempotence.
Like in computing.
Exactly. Design actions so that doing them multiple times has the same effect as doing them once. Critical for reliability, especially on a blockchain where things can sometimes get uncertain. You don't want to accidentally double spend or place the same order twice. Right. And connecting back to that globalized learning idea, how do they make sure a small failure isn't just swept under the rug, silent, and therefore never fixed?
Through observability by design. The charter is explicit. Silent failure must be impossible. The system must constantly emit meaningful logs, metrics, traces. If something goes wrong, it needs to scream about it, basically, immediately.
And that feeds the improvement loop.
Directly into it. That tight iteration cycle we mentioned.
Yeah.
The anti-fragility feedback loop.
Right, that cycle. Sense stress is strengthened. Can you walk us through how that might work in practice, like in real time?
Okay, so first, you sense. Gather the current state of the world, the market. And it's mandated. Use diversity. At least 2 independent sources for critical data.
Okay, sense with redundancy then.
Then you stress that understanding. Before you act, you probe your assumptions. Run adversarial tests against edge conditions. What if this price feed is wrong? What if the network lags? You stress test the plan before executing.
Proactive paranoia almost.
Kind of. Then you adapt. Based on the sensed state and the stress tests, you select the smallest, least risky, viable change that addresses whatever constraint or opportunity you've identified.
Smallest change, not the biggest potential win.
Smallest viable change. Minimize downside, remember, bias to reversibility. And then, crucially, you strengthen. You write the lesson down in code. Add a new guardrail, a new invariant check, so that exact same failure pathway is closed off for the future. Systematic error immunization.
That's incredibly rigorous. Can you give us a concrete example, specific guardrail that just stops things cold if conditions aren't perfect?
Yeah, the charter details one very specific, non-negotiable engineering constraint. The three-way agreement.
Three-way agreement. What needs to agree?
Before any action, like placing a trade, is actually executed, three distinct parts of the system have to be in perfect sync. The market quote received, the instruction payload generated for the blockchain transaction, and the simulator's predicted outcome of that transaction.
Quote, payload simulator prediction.
All three must match perfectly. If there is any discrepancy, even a tiny mismatch in amounts, price limits, slippage parameters, anything, the action is immediately aborted. Full stop.
Zero tolerance for ambiguity. That sounds computationally expensive, maybe, but incredibly safe.
It is an extreme level of diligence, yes. They also mandate absolute unit discipline.
Unit discipline.
Strict rule. All calculations involving token amounts must be done using Mint base units. So for you listening, that means always working with the smallest possible integer value of a token like Wave for Ethereum or Lamports for Solana. No floating point numbers for amounts, ever.
To avoid those nasty rounding errors you can get with decimals in computers.
Precisely. Especially with crypto tokens that might have 6, 9, maybe 18 decimal places. Using base units, integers, eliminates a whole class of potentially catastrophic financial bugs. It's meticulous correctness, right down at the fundamental level.
Okay, this is where, for me, it gets really fascinating. We're connecting these deep philosophical rules, these strict doctrines, right into the hardware and the network infrastructure. We're now talking about this automated system running in trading mode on the Solana blockchain. How does that philosophical demand for, say, redundancy and pluralism actually show up in the engine's structure? Like physically, how is it built?
It shows up immediately.
Yeah.
Right in the data ingestion architecture. The Charter's principles, especially prefer redundancy over precision, are baked right in. They explicitly avoid relying on just one way of getting market data.
So how does that look in practice? Multiple connections.
Yeah, it's a tiered hybrid approach. Tier 1 is high priority. This is for capturing the most critical real-time market events very quickly. The system uses persistent high-performance WebSocket connections for this.
Like streaming data.
Exactly.
Yeah.
Real-time, low-latency streaming. The logs we saw mentioned using providers like Helios RPC for this, focusing on a select number of important liquidity pools, maybe 12 or so in the example log. This is the fast lane for the most crucial data.
Okay, so Tier 1 is the speedboat. What's Tier 2?
Tier 2 is batch. It's the methodical backup and broader coverage. This uses standard periodic batch polling over regular HTTPS RPC connections. Think asking for updates every second or so, rather than getting them streamed instantly.
Slower, but reliable.
Slower but reliable, and covering potentially a different set of pools the logs mentioned, around 9 pools for this method, maybe less critical ones. And crucially, the system doesn't just pick one provider. It explicitly initializes connections to multiple Solana RPC providers.
Like the ones mentioned, Helios QuickNode.
Yes, Helios QuickNode plus a specifically designated fallback provider. So it's not just about having a backup if one fails. It's about concurrent pluralism. It might be listening to multiple sources at the same time. If the high-speed WebSocket stream has an issue, it can likely rely on the batch data it's also collecting while it tries to reconnect the stream.
So redundancy is live and active, not just a cold spare.
That seems to be the design.
Okay, so the engine's main job isn't just blindly firing off orders then. It sounds more like a really sophisticated, stateful filter and decision support system. It's constantly monitoring all these events from multiple sources, maintaining this critical picture of the market. They call it a live liquidity map, and only then deciding whether to act.
That's its core function, absolutely. Constantly maintaining state, comparing the new balance it sees in a pool against the previous amount it had recorded, calculating the change. But, the sheer volume of events on a fast blockchain like Solana is enormous. Most of it is just noise.
Right. Tiny fluctuations, arbitrage bots fighting, things that don't really signify a major shift.
Exactly. So the system has to be discerning. It needs that crucial gate, that filter, to separate the background noise from potentially actionable signals.
So what is the key mechanism for that separation? How does it decide if a change is just jitter or if it's something worth paying attention to?
It's an explicit filtering step in the logic. After calculating the liquidity change, it finds the relative change, like the percentage difference. Then it compares that percentage against a static, predefined threshold.
A fixed threshold?
Yes. And the document is incredibly specific about this value. The threshold is set at 0.0010%.
0.001%. That seems incredibly small, like vanishingly small. Most trading systems would probably ignore changes that tiny, wouldn't they? Just treat it as dust, microvolatility.
They absolutely would. Normal noise filtering would likely use a much higher threshold. For the Copilot, this 0.00010% seems to be the definitive line in the sand. If the calculated relative change is, say, 0.0000%, basically zero, or less than the threshold, the event is explicitly marked as rejected, logged and discarded.
So only liquidity changes above that tiny threshold even get considered for further action, like going into the simulator.
That's how it appears. Only activity that crosses that static boundary is passed along the chain for potential actioning, simulation, and maybe eventually execution.
Okay, this 0.0010% threshold. This connects directly back to the philosophy, doesn't it? Back to that Latin motto we started with. De discrimin, mas from discernment, method.
It ties it all together perfectly, especially if you think about the engine in like thermodynamic terms as a dissipative structure, something that maintains itself by processing energy, or in this case, information flow.
How so?
Well, the constant churn and volatility of the market, that's the decontenzione aerober part, right?
Right.
The tension that provides the potential for strength. The market is always fluctuating, always under stress.
Okay.
But most of that is just random thermal noise, you could say. It's only when the tension accumulates enough energy, enough focus change to cross that specific tiny 0.001010% threshold. That's the moment of de discrimin, Moss. That's discernment creating method.
So the threshold is the critical point, the phase gate, as they might say.
Exactly. It's the crystallization point where accumulated disordered tension is recognized, filtered, and potentially metabolized into an actionable, ordered method. It separates signal from noise using this fixed, albeit tiny, rule.
So it's not just exploiting inefficiency, it's actively metabolizing market disorder, the volatility into order, which could be profit, or maybe just a stronger internal state, a refined principle.
That seems to be the core idea. The volatility is the fuel, and the system strengthens itself, generates order, regularly, by processing that stress according to its method. Moss.
Wow. And that relentless drive for like impeccable execution, it even shows up in their standards for just workmanship, right? How code should be written, how people should communicate.
Yeah, it extends everywhere. They mandate that code must be readable by adversaries. Think about that. It has to be so clear, so logically sound, that even someone trying to break it would look at it and struggle to find an exploitable flaw.
That's a high bar.
A very high bar.
Then,
And software tests should teach, meaning the name of the test should describe the symptom it prevents, making the system safeguards self-documenting. It's all about clarity, accountability, even their communication rule. Brief, brave, bounded. Clear, concise, unambiguous.
so wrapping this up, what's the big takeaway from this deep dive? It feels like the structure itself, the way this thing is built, is the teaching.
I think that's exactly right.
The deepest lesson maybe isn't really about coding or finance even, but about creating a set of rules and operating system that's so robust it not only allows for adaptation, but actually requires it to function properly.
Because they do mention that, right? Despite all the rules.
Yes, despite the rigidity, the charter explicitly states, if the heuristics call, we can deviate and under pressure change, there's an escape hatch.
So ultimate flexibility built upon ultimate rigor.
That seems to be the core tension, the ultimate anti-fragile stance. Hold firm to unwavering principles and meticulous standards, but also retain the freedom to adapt, to deviate intelligently when a fixed rule becomes a constraint on excellence, especially under pressure. The principles guide the ship, but adaptation steers it through the storm. The charter's final words really stick with you. They feel like a challenge, not just to the systems builders, but maybe to you, the listener, whether you're running code or running a company or just, running your life.
What are they?
Be quiet in ego, loud in evidence, swift in remedy, slow in regret. And the ultimate goal they state for this system, that others seeing its work, its consistency, its flawless execution, even when everything's falling apart, might mistake them for inevitabilities.
Inevitabilities. Wow. That's the real mastery, isn't it? Making the incredibly difficult look like the only possible outcome.
So the final thought to leave you with is this. What would it take in your own work, your own operating principles, your own rules for life or business to achieve that level of structure, that level of resilience, that your positive outcomes start to look inevitable? What would that require?
That's the essence of trying to build something truly anti-fragile, I think. Making strength from chaos seem like the natural order of things, a profound challenge.